Okay, so this is means, right? Means, averages, not proportions. Okay, so we have two options. Remember, for means, we always have two options, Z and T. Most of the time, it's going to be T. But how do we know? If the population standard deviation is given, it's Z. If it's not given, which most of the time it will not be given, we will have a T situation, right? We had that in chapter 8, right? All right. This is the same thing. You literally have this in your notes from last time because it's the same question. We're asking the same question, just not with proportions, with means. Okay? It's literally the same steps, the same 7 steps. Now, are they all the same? No. Number 1 is different. Number 4 is a different formula. Number 5, some of the conditions look a little different, but essentially it's the same 7 steps. Okay. How we write our hypothesis is the same. The only difference is we're going to be over here. This section, we're over here. Right? We're not with the p's because that's not proportions. So our null is always going to be the true mean equals something, equals a number. That same number will be over here too. We just got to decide if it's greater than, less than, or not equal to. Just like we did last section. Okay. Significance level is the same idea as a significance level. That's not going to change. Remember, if our p-value is too big, if our p-value is smaller than the alpha, we reject. If it's bigger than the alpha, we fail to reject, but we never, ever accept. We never say that the null hypothesis is true, or I accept that as the answer. No, we just either say we reject the claim, we have enough evidence to say, no, it's wrong. Or we fail to reject. I don't have enough evidence to say it's wrong. Okay, same as last. That one hasn't changed. Here's one of the new parts. We have 2 new formulas. There's z-score and there's a t-score one. So t, z, just depending on which one. Okay. They look very close. They look very similar. The only difference between them is one has the standard deviation population, one doesn't. This is the sample standard deviation. S is the sample standard deviation. So if we have the population standard deviation, great, use it. It's Z. If we don't, it's T. Okay? That's the only difference between the two. Okay? And they look very similar to the ones we did last chapter. Where is the formula? Formula somewhere around here. This guy right here. It's very similar. Okay. Again, the bottom are both given on your formula sheet. The top is just subtraction. It always starts x bar minus the mean, the true mean.
Is this on the formula sheet, or is it something we have to remember?
One more time, I just said it. This right here is on the formula sheet. The top is not, but it's always the same. If you look at the top, it's always the same. The sample minus the true mean. The sample minus the true proportion. That's how it always starts. And then the bottom is given. This part is given. This part is given. That part is given on the formula sheet. Okay. Assumptions, conditions, 1 and 2 are always the same. Number 3, since it's means, we have 3 options. We don't do n times p is greater than or equal to 10, n times p is less than or equal to 10. We don't do that for proportion or for means. Okay? So that's the one. These are our 3 options here. We've done that in chapter 8 though. So it's not anything we haven't done. Our conclusion is the same sentence frame. Same exact sentence frame. Interpreting the p-value, same sentence frame as last set of notes. Okay. All right, so let's get to a problem. Let's get to a problem. I gave you 2 examples. There's not a lot because once you start getting this, you're like, oh, it's very simple, very, very similar to what we did last week. Okay. Okay, so example number 1. How smart are AP statistics teachers? Human intelligence can be estimated using an intelligence quotient or an IQ. Okay, one of the ways to monitor how smart a person is, or their intelligence, I should say, not how smart, their intelligence, is their IQ score. Okay, the distribution of IQ scores for the adult population is approximately normal. So if you were to test every adult in the world, give them an IQ test, graph it, it would be normal. The average would be 100. The average is 100. The average, if you're an average intelligence, you got 100. If you're bigger than 100, you're above average intelligence. If you're less than 100, you're below average intelligence. Okay. Some students hypothesize that AP teachers have a higher mean IQ score than the general adult population. Okay, that's their claim. They select a random sample of 10 AP teachers and record their IQ scores. Okay, here are the results. So those 10 had IQs, these were their IQs. One teacher had an IQ of 106, IQ of 114, IQ of 121, IQ of 95, so on and so forth. Okay? Do the data provide convincing evidence at the alpha level of 10% or 10% significance level that AP teachers have a higher mean IQ score than the general adult population? Okay, so a lot to unpack there. First thing is, how do we know it's a test? How do we know that this question is asking us to do a test? There's a couple clues. What's one clue? There you go, right? We're used to seeing that. Provide convincing evidence. That means test. There's another way to know if it's a test. What's the other way to know if it's a test? Yeah, they wouldn't give a significance level if they didn't want us to do a test. So those two tell us test, right? We have a means, right? Means, higher, mean. So we know it's means. Is this going to be T or Z? It's going to be T. I don't have the true standard deviation for all AP teachers' intelligence IQs. I don't have that. Okay? I don't know that number. So because I don't know that number, this is going to be a T model, what we call a T model. Means I'm going to use the back of my Z-score chart, not the front. Not my Z-score chart, but the back. Okay? All right, so what else are we missing here? Let's see here. Do I have a sample size? 10. And then I also have this guy right here, approximately normal with a mean of 100. Mean of 100. What is that mean of 100? Who does that refer to, the mean of 100? The entire population. So the true mean right there. So that's the first thing we're going to do is population parameter. Okay, we know the number is 100. So that number represents what? The true mean IQ score of the adult population, right? Okay. That's our population. That's who that represents. Then we have two hypotheses. Always have two hypotheses. This one's going to be mu, or the true proportion. So what's the claim? The claim is that the true mean score is 100, the same as the population, the adult population. So that all 100 is going to go out here actually too. So we have three options: greater than, less than, not equal to. Which one are we going to use for this guy? Greater than, because of the higher. AP teachers have a higher. We don't care if they have a lower. We want to know if they have a higher. Greater than. It didn't say a different. It just says higher. We want to know if they have a higher mean IQ score. Okay. Significance level, they told us this time. 10%. That's probably the lowest threshold. The lowest threshold. Remember, if I want more evidence, if I want to raise the bar for evidence, I'm going to lower the alpha level score, the significance level. Okay, next thing is I got to check my conditions, assumptions. SRS, 10% condition. And then is shape approximately normal. Okay. So the sample, believe we had a sample of 10. It said a random sample of 10 AP teachers. Okay. So stated. Good there. 10% condition. N is less than or equal to, wait, no, it's less. Is it less than or equal to? 10% of big N. Well, we have little n, right? If little n is 10 from the 10 AP teachers, who is big N? All AP teachers, good. Don't have a number for that, but for that to work, it has to be greater than 100. Pretty sure there's more than 100. There might even be more than 100 in Fresno. Okay, so pretty safe to say that there's more than 100. Okay. Last one is shape normal. So this is where it differs. This is where the conditions differ from proportions, right? The third one, we have three options. Given that the population is roughly normally distributed, in other words, they told us in the question. They didn't tell us. Number 2 says they didn't tell us, but our sample size is big enough. Number 3 says neither, so we have to check the data to see if there's any outliers or strong skewness. So which one is this one going to be? 1, 2, or 3? Number 1. Yep, they tell us approximately normal. They say adult population is approximately normal. That's why I underlined it earlier, because I knew we'd need it later. Population stated as approximately normal. Okay. Next one, formula. You don't have to write both. You just have to write the one you need. I put both on here just because we hadn't decided yet. Okay, so if it's T, you're going to choose the one that says T equals. If it's Z, you're going to use the one that Z equals. So the one we have to do is T. So that's the one we're going to write down. We would write down. Remember, with T, you have degrees of freedom, right? We have degrees of freedom. It's at -1 still. Okay. Calculations. Okay, let's draw. Okay. Claim goes in the center. The claim was 100. I need to subtract that from X bar, right? Do I have an X bar yet? Or a S, standard deviation? I don't, right? That comes from the sample. So what I should have done at the very beginning was done all of that. Oh, well, now I can do it now. So what I need to do is I need to find out what the sample average is for those numbers and what the sample standard deviation is of those numbers. Okay? So you can just put them in L1 and figure that out. Let me do it up here. Let's see. So we need to find the sample average of those 10 numbers and the sample standard deviation. Okay. So L1, let's see, 106, 104, or 114, 121, 95, 125, 102, 10, 103, 99, 108. Stat, calc, 1var stats. My list is in L1. Here we go. So our sample average is on 108.3. Our standard deviation, S of X, is 9.499. Okay, those are the numbers we're going to use. So our sample mean was 108.3. Which way do I shade? Less than or greater than? Greater than, because that's the way I said in the hypothesis. That's going to be my p-value. Okay, so here we go. T equals 108.3 minus 100 over the standard deviation, which was 9.499 divided by the square root of 10. Okay. So you can crunch those numbers just like you've always, or like I said, the calculator has, let me show you the calculator. Since we have those numbers in L1, I'll show you something. So if you go to stat, test, it's not going to be the ones that say proportions because that's for proportions. So 5 and 6 are not going to work. And everything below that is an interval. So it's going to be 1 through 4. So which one of those 4 do you think it's going to be? 1, 2, 3, or 4? It's going to be number 2, yeah. 3 and 4 are 2 samples. That's next chapter. Next chapter, we'll have 2 different samples. We only have 1 sample. There's 1 sample of 10. So it's either going to be 1 or 2. And since this one is T, this one is going to be this guy. We have 2 options, data or statistics. Remember, data is when I have the numbers in L1 or L2 or L3. Okay? Statistics mean I don't have the exact numbers, but I know the mean and I know the standard deviation of them. So we can use either of these. I always use data when I actually have the data. So if I have the data, I might as well use it. It's in there. It's in L1 for a reason. Do you have to use data? No, you could use statistics and just plug in the standard deviation. Like you could use this one and then plug in, okay, the mean is this. It actually is already in there. So if I have the data, I have to put in my claim. The claim was 100, right? I list L1, frequency you don't mess with. We want, what was it? Less than? Greater than? Greater than. There we go. Again, you have two options, calculate and draw. I like draw sometimes because it shows us what our picture should look like. We've already drawn our picture, so it shows what our picture should look like after we've shaded it. Okay. And then down at the bottom, it'll give us two numbers. It'll give us the t-score, and it'll give us the p-value. Okay, so the t-score, t equals 2.7631. The p-value is 0.011. Let me show you something real quick. So if I had done, let's see, calculate actually would show you degrees of freedom too. Does it show you? I thought it did. No. What is degrees of freedom for this problem? 9. N minus 1. Right? If you're going to use the table, remember degrees of freedom like we did last chapter. Okay. Actually, you know what? The table's a little different. So let's say we're using the table. Let me show you the table. So, because sometimes they make you use the table. So let me show you the table since we got a little bit of time here. Okay, so how do I do this if I had the table? Right? First thing you have to do is calculate this guy right here, right? Can't see it. First thing you're going to do is calculate that guy, right? That's the first thing. If you're going to use the table as opposed to the calculator. Then you're going to go to the table. We know we have 9 degrees of freedom, right? We know we had 9 degrees of freedom because we had a sample size of 10. Those are all t-scores. We're going to go to the one that's closest to our t-score. Which one of those guys is closest to the t-score that we got? So our t-score was 2.76, right? So the one that was closest to it is, I think, that guy there. Right? It's actually between two, right? It's actually between two. It's actually between these two guys, right? It's actually between those two guys. So we're not going to get an exact p-value, but I am going to get something that's close. I'm going to get a p-value, and then I go to the top. I'm going to get a p-value that's in between those two guys. My p-value, using the table, you can't be exact, but you know it's somewhere between 0.01 and 0.02, which our p-value was, right? 0.01 something. So if you use the table, you can approximate your p-value, but you can't get exact, right? I'm guessing that since my t-score was a little bit, since my t-score was a little bit closer to the 2.8 guy, it's going to be closer to this guy right here, right? Our alpha level is 10%. So even if we can't be exact, we're still close enough. We're still good that we can make a decision on our conclusion. Okay? That's how you use that guy to get the p-value. Okay? Last thing. 3 things we need to cover. Same 3 things we did last chapter, or last section, last week. Here we go. Let's see. Since p-value, our p-value was 0.011, our alpha level was 10%. So this one is going to be a less than. The p-value can fit inside of the alpha level because it's small enough. If that's the case, it's less than. If that's the case, we're going to reject. We reject the null hypothesis. Okay. I should have done this in red. Reject. Therefore, we have sufficient evidence to suggest that, and then here is where we have to put in our alternative in words. Our alternative was true mean score is greater than 100. The true mean IQ score for AP teachers is greater than 100. What's that? For the adult population of the if we were to put that, we didn't answer the question, right? Because the question wants to know, are the AP teachers have a higher mean, right? So if we don't put AP teachers, then we didn't answer the question. And we're okay saying AP teachers because that's where the sample came from. The sample came from only AP teachers. There was no anybody else besides them in the sample. So we were comparing this sample versus the mean of everybody, all adults. So we have sufficient evidence. So even though the true mean for every adult is 100, for AP teachers, based on our sample, it's actually bigger than that. Okay? That's what that says. Okay. What was I going to say?
For the calculations, if we use the calculator and we didn't write anything like on paper, do we state that we use the calculator to find like the p-value?
So if you want credit for calculations, you need 2 things. You need a picture, and you need you need 3 things actually. You need a picture, you need a t-score showing your calculations, and you need a p-value. So if you're missing one of those things, they'll dock you on that. So those are the 3 things you need for calculations, to get credit for calculations. So picture, p-value, and then the t-score. Even if you put t equals this, and don't put how you got that, they will dock you because they need to know where your process. How did you get that number? I know your calculator gave it to you, but what did your calculator do to get that? Well, it used this, right? So always have this down there. And then how you get this number is up to you. If you want to use a calculator, great. If you just want to crunch the numbers, that's fine too. Okay. Same thing here. If you want to use the calculator to get that, great. If you want to use the table to get that, that's fine too. But just make sure you have a p-value. Okay.
Those three has to always be on there.
If you want full credit for calculations, they need those things. Okay. Just like for test statistic, they need the formula. I need one of these formulas to identify it. It's a way of identifying what procedure you're doing. Because we only use these formulas for one sample, Z or T hypothesis test for means. Okay. Let's see here. What was I going to do? I forgot something. Can't remember it for the life of me. I can't remember what I was going to say. Yep. If I think about it, I'll bring it up to you guys tomorrow. But yeah, for some reason I can't think about it. So we will finish. We'll do the last question tomorrow. Okay. I might give you, if we have time, I might give you an extra problem to do on your own, but that's all we're going to do. Wednesday, I'll give you time to do the assignment like I always do in class. And then we have one more thing to talk about in this chapter, and then we're done. So we'll finish this chapter this week. So next week, we got another test coming. These chapters go by fast. Uh-huh.